Okay, so here is an experiment with um, SoanPapdi FPGA board. So I want to store a 8-bit data and not 8-bit data. I want to store 10 8-bit data. Actually, I can store 16 8-bit data because the address is 4-bit. So 2 to the power 4 is 16. I can individually address 16-bit into the buffer and store. So this is the main block that I created, and as you can see, it can take input of 8-bit data. Given that write pin is enabled, it will write into the buffer, and if the read is enabled for the same address, so you see read index and write index are actually connected with the same address. That's my requirement. So any address given, it will either write or read. So will it read or write depending on this particular pin B2. So when I'll show you in the SoanPapdi board the B2 sliding switch, you will know if it is on, then by default the write will be enabled. If it is off, then because it's a NOT logic, it will be read enabled. And then finally the address, at which address we are reading or writing, that will be decided. The clock is the internal clock of SoanPapdi board, which is the lattice ice FPGA board, which is like 48 megahertz I think. And finally, if it is a it's a read mode, then the output will be shown in the 8 LED pin connected with the SoanPapdi. So let's see the demo. So by the way, this is a starting point or baby step towards a bigger project where I want to show integrating Arduino with SoanPapdi, because the SoanPapdi is a bare metal, and basically you will see FPGA works hand in hand with a processor or microcontroller. So there is no microcontroller here to work with. So I want to integrate Arduino. Arduino will make things done by using the expertise of SoanPapdi, the parallel processing, the multiplier inside, and it will get the work done. So the work I have thought so far for experiment is matrix convolution. So two matrix, I will give a image matrix or something, and one convolution matrix I will keep inside this, and it will apply the convolution matrix throughout the whole image, and then it will return the whole image back. So I want to see, maybe I can give a rotation matrix that will rotate the whole image, and after convolution the image will be rotated and returned back, or maybe noise cancellation or whatever. We'll think about that later. For now, and this is just a experiment purpose, I will not go in complication for the convolution network. What is going to be something very simple I will try, and maybe we'll try to check the timing. So okay, so this is the board, and then you can see the name, whatever I mentioned in that schematic diagram. So B0 to B3 and A0 to A3 are the four 8 buttons, that is the input button, and this LEDs are D0 to D7, they are the output pins, and they have some other pins. I'm not going to use it right now, but after doing this simulation I am really going to use those pins, because these are hard coded. I mean, I can do it manually, but how fast I can do, I cannot show that. So in Arduino, automatically it will be passed here, and I will be using some extra pin. Thanks for giving extra pin other than 8 bits. So I0 to I7 I will be sending data pin, and I8 and I9 I will use to communicate, like acknowledgement. So I have sent the data, read it please. Then SoanPapdi will say I have read, this is my acknowledgement. Then the other side will say okay, this is the next data. So those kind of handshaking and all will show. So okay, coming back to our main project here. So B1 and B0 are the data, but right now B2 is off. So B2 is off means this NOT will activate, means it's in a read mode. So because there is nothing in the buffer, you see the bulbs are not glowing. Now I will try to store something. So for that, what should I do? I have to first of all change the B0 and B1 value, and then bring the B2 to on mode. So if I switch on the B2, it will be writing to the memory, and in which address? That is defined by A0 to A3. So first let me ensure A0 to A3 are 0, means I am addressing the 0th location using the A0 to A3, this whole pin, A0 to A3, and they all are 0, means I am pointing to the 0th location. And what I am storing, B0 and B1 both 1, and I am not yet stored because B2 have to be on for that. So let me switch on the B2, and yes, it's red. So how to know it's red? So now we'll switch back to off, and you see, I mean, if I off it, it will be in read mode. It will read the same memory location, and you see they all are on, means B2 has stored these two pin. They have replicated the same thing again and again. How they have done? So I have used this two pin and fed it into a dummy 2-bit to 8-bit converter that I have created. It's a simple code where I'm just copy pasting the bit 1 in first 4-bit and bit 2 in the second last 4-bit. So which one is MSB and LSB, you can see from the sequence. Okay, so I'm not going to that details. So you can understand each bits are consecutively 4 times replicated in the code. So now I'll go back. So here this is what the data is passing, and that's why you see all the pins are on. Now I will change the value. I will change it to B2 off, B1 off and B2 on, and then which address I want to feed it, I will feed it into A0 equal to 1, means the next memory address. So next memory address, it's immediately started reading because B2 is in read mode and A0 is the 1th location, not the 0th location. In 1st location there is no data yet, so it's blank. Now I'm going to read it. So I will switch the B2 to on. Now its reading is done. I will bring it back to off, means it's reading the memory. So now it's reading the 1th memory, not the 0th memory. 1th memory has only B0 as 1 and B1 as 0. So this is what is reading. Now while it is reading, in the meantime I will switch back to the all 0 mode, means all the address pointing to 0. A0 is also 0. And what you should see, the previous value that I stored in the buffer, which is all on. So let's slide it down and see what happens. And see, all on, which means now at the 0000 location it is reading and showing me the buffer data which I gave earlier, not right now, and that data is still remembering, and that's what we want, right? So this is the memory thing. Or okay, randomly I will choose one more memory. So let me go to this one. So 00, if I read from A0 side, 0010 is the memory location, and let me store the opposite one. So let me switch off this and on this one, and then store this value by this. So okay, the data is already read, and now I will first I have to be in the read mode. In write mode, if I do anything, that will override the last read. So now I can switch between. So this is the mode where it is reading the, oh, I think it was not on properly, so it didn't read the value properly. So now let me on one more time and then off it back. So now it is reading. Now I'll go back to all 0. It's reading, and then the first data, second data, and the, oh, I think so both the data I think I stored the same. Better let me do this and this the other way, and 0001 I will store this value, and then, oh, this is the loose connection thing, so I have to make it really tight to write this. So now I'm reading this and it is storing this value. Now if I go back to 0 1 of 1, oh, the value was here. Okay, so it's a little difficult to play with this sliding buttons and doing till the end, but at least I understood that the code is seems to be working, the dummy code. So this is the dummy code. Finally I'm going to remove this whole block, is I0, I1 from the dummy, everything. So I'm going to remove this whole thing from here, and I'll delete this, everything. I'll delete this also, and instead I will connect this to the I0 to I7 pin. So I'll just connect it to the I0 to I7 pin. So if I go here, basic input, I 0 come on 0 to, so 7 to 0, there is right. That's the convention I see, 7 to 0, not 0 to 7. And then here I will be using those pins I0, I1 and so on. And so in that case it will not refer to the sliding buttons, it will refer to whatever comes from these pins. And that's where I'm going to connect my Arduino to show this example will help students in different way, like they can know how the handshaking happens, how the packet sends and acknowledgement happens, or suppose the package is not transferred properly, you will not get acknowledgement, you have to resend the packet. It's like the very common thing about TCP protocol, any packet transfer